Yeah, g'day, how you going? I'm out at Rob, this is James, Cobster, and we're doing our presentation on the air valves.
Yeah, I'll take me here, Cobster. Well, anyway, we're going to be talking about a few things today regarding air valves, what they are, how they work, and what information you need to know about, and what the problems are regarding them.
So you'll find these bad boys in almost any pipeline, water infrastructure, transportation.
I mean, the real issue is the air that gets entrained in it, and there's about 3 different methods how this happens. Firstly, the actual air that begins in the pipeline. As the water comes through, a lot of it remains in the pipeline after the water gets flowing. The other issue is the water itself. It's actually about 2% air, so a lot of it remains in the pipeline as the water's flowing. And finally, the mechanical equipment as well. I mean, it does its good things, but also it brings a bit of air into the system and can lead to some serious problems.
That's right, Cobster, and there's a few issues that come with this. The excess air can lead to water habit or cavitation, and this can lead to burst pipes or incorrect meter readings. As you can see from the diagram, the air rises to the high points.
You see, the funny thing is, air is actually lighter than water, so it's going to rise to the high points. And if you got this problem, you're going to be using your pump harder, using more energy, and costing money. Isn't that right, Cobster?
That's right. So, Cobber, as air from the pipeline enters the valve, it displaces the water, allowing the float to drop. The air is then released to the atmosphere through a small orifice. As the air leaves the valve, it is replaced by water, lowering the float and closing the valve's orifice.
Wait, so as air accumulates, does the valve continue to cycle through in this manner to remove the air?
It's too right, man. So there are 3 common types of air valves. It's the air release valve, the air vacuum valve, and the combination of both of these. So the air release valve is the most common type of these valves, and they're recognisable by the small orifice and leverage mechanism.
Air/vacuum valves are usually quite a bit larger. The orifice is bigger than other types, and it also enables them to exhaust far more volume or air volume than other types. The main difference, though, is the mechanical linkage between the valves. Unfortunately, they can't operate while pressure.
The 3rd type of air valve is the combination valve, which is a combination of the air release valve and the air vacuum valve. This is the best of both worlds. It can be achieved in a dual body design or a single body.
Any would-be engineer out there trying to design any sort of system that involves air valves has to know the requirements for the installation. They include design guides and parameters.
That's right. You're going to want to get these at the high points or the peaks of the system, or slightly downstream of these points, and generally paired with the combination as mentioned in the previous slide.
Hey Cobster, don't forget the importance of the sizing though. Design guides, design guides, design guides. These consider the pipe size, the flow going through, and everything in between.
That's right. Incorrect sizing can lead to positive and negative pressure surges. This can lead to catastrophic pipeline failures.
Jesus, Cobster, you wouldn't want that in your system.
Alright, Robbo, that's enough from us today. That was a quick and dirty design guide to air valves.
If you want to find out more as an engineer, check out some of our websites we've provided on the slides, or come over yarn with us in the Civil Suite. We'll tell you all about it.